Okay, so welcome to this small video, which is just a recap of how to take determinants of matrices. Okay, so remember, if you have an n by n matrix, then you can construct. If you have an n by n matrix, you can construct something called a determinant of that matrix. Which is basically it maps a determinant. This det function is going to map any matrices, the ring of matrices, over the real numbers, and it's going to map it onto the real numbers. So it's a function from this ring of matrices. This is a ring because you can add any two matrices together, and you can multiply any two matrices together. But the I isn't necessarily going to be a multiplicative inverse for every element. Specifically, there's not going to be multiplicative inverses when the determinant is equal to 0, which is why this map is so important. Okay, excuse me. Okay, so let's start with the ring of matrices of 2 by 2 matrices. So that is all matrices of the form. So it's the set containing all matrices of the form A11, A12, A21, A22, where the AIJs are all elements of the real numbers. Okay, so if you want to take the determinant, there are many ways of denoting the determinant. Either you can just write the matrix with square vertical lines on either side, so A11, A12, A21, A22, like that, or you could write det of, let's call this matrix A, or sometimes you'll just see this written vertical lines A with A in between, and this is going to be equal to this one up here multiplied by this one. So this horizontal multiplied by this one, A11, A22, subtract this one multiplied by this one, so A12, A21. Okay, so that's how you take the determinant of a simple 2 by 2 matrix. And note, the way that you take the determinant of a more abstract matrix, so that we can use this one as an example, is that you need to sum up, you need to take the sum of every single possible combination of the AI, well, what you basically have to do is you have to pick one element, you have to go down the rows, and you have to pick one element from each of the rows and multiply them all together. So if we have 3 rows, you'd have to pick one element from this row, one element from this row, and then one element from this final row. But you also have to pick them carefully so that you get one from each column as well. So I cannot pick this one with this one basically, because then I would have 2 in the same column. So you have to only have 1 in the same column and 1 in the same row. You have to have only 1 element from each row and each column. So you can pick this one, and you can pick this one and this one multiplied together. And the way that you decide whether it's whether the coefficient is going to be negative or positive is based on how many permutations you have to make to get it in the right order. And let me explain what I mean by the right order. So the right order is that you pick some elements from column 1 basically, and you want okay, let me go on to another piece of paper. Okay, so let's do the example of the 3 by 3 matrix so that I can show you what I mean by the right order. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so we want to take the determinant of this. So again, we need to look at all possible combinations where you pick 1 from each row and 1 from each column. So let's say we pick this element here from the first row. Then we have 2 choices. We could for the second row, we could either pick this one or we could pick this one, because we can't pick this one, otherwise we'd have 2 in the same column. Okay, so let's say we pick this one, then we are fixed after that. There's only one we could pick after that, which is A33 rather. So we have A11, A22, A33. Okay, or we could have picked this one, then we could have picked this one instead, and then we'd have to pick this one here. So we'd get A11, A23, A32. Okay, okay, so that's all the possibilities for picking A11 here. Alternatively, we could have started by picking A12 from the first row, so we'll put A12. Then we could pick A21 from here, and then we'd have to pick A33 from here. To get one in each, you have to pick an element from each row and only one element, and each column. So here we have a row, an element from each column and an element from each row. Okay, then we could have picked A12, so we don't know whether it's a plus, so A12, then A23, and then it would have had to be A31, and then the final ones are we have A13, we could pick A21 here, and then we'd be forced to take A32, or we could pick A13 to A22 and then to A31. Okay, so that is the those are all the possible combinations that we have here. Okay, so now what we have is we have to decide whether the coefficients are positive or negative. Okay, and the way that you decide whether they're positive or negative is you look at each choice. So here we had, for this first one here, let me just highlight it again to show you what we had. We picked A11, A22, and then A33. So that corresponds to that one. That is in the perfect order, because the element that's in the first row and in the first column is up here. The element in the second row and the second column is here, and the elements in the all these elements are basically in the perfect position. So A11 is the element in the first row, and it's in the first row, so basically, let me show you how another element is not, another one of these is not correct. So, for instance, if we took A11, and that's an awful pen, so it doesn't do what I want it to do, which is highlight it. So let's pick this one this time, do this over here, A23, A32. So that's this option here. That is not in the perfect order, because this element is in the second column, but it's not in the second row. So we want the element in the second column to also be in the second row, and we want the element that's in the third column to also be in the third row. This element is in the third column, but it's not in the third row. So we have to now do a permutation, or we have to do a row switch here to make them into the right one. So we would have to swap these two. And basically, the number of permutations, the number of row switches you have to do to make the order correct, that is called the sign of the that's going to determine the sign of here. If the sign is odd, if the number of permutations you have to do to get it in the right order, in this case you have to do one permutation. You have to permute this row here with this row here to bring this one down and put this one up. Then that is going to have a negative sign, because you've got an odd number of permutations you need to do. If the number of permutations that you need to do is even, then you put a positive sign. So this one, the number of permutations you had to do, it was in the perfect order already. It was 0, so that's an even number, so you'd have a positive in front of there. So let's do some more. So let's have a look at A12, which is this element here, A12, A21 over here, and then A32 over here. Right, so everything's in the wrong place here. But oh wait, no, that's not right. A33. So that's not a possible pick, because we had two elements in the same column there. So we had A12, A21, and A33 here. So this element is in the right place. This is in the third column, and it's also in the third row. But this one here is in the second column, but the first row, and this one's in the second row, but the first column. So those two need to be swapped around. So we've got again one permutation to get those right. So we've got a negative sign in front of there. Let's do this one now. A12, which is we probably need a new picture now. So let's just do a new picture. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so let's look at this one. A12 here, A23 is here, and A31 is here. So absolutely none of those are in the right position. So this is in the second column, but the first row. This one is in the third column but the second row, and this one is in the first column but third row. First column but third row. So okay, this is more interesting because look, we're going to have to swap these two round firstly to get this one up here, but then we'll bring this one down here, and then once we've done that, we're going to have to swap this one with what's now here. So we're going to take this one up to here and bring this one down here, and then we'll have to swap those two around. So we'll have to do two permutations to correct this. So it is again even, so we'll put a plus sign in front of there. Okay, next one, A13, A21, A32 is, let's get the highlighters back again. It's this one here. A21 is here, times A32 is down here. Okay, so again, this is all wrong. So firstly, let's permute these two round. So we bring this one up into the correct position, this one down here, and then what we're going to have to do is swap this one again with this one. So that's again two permutations, so it's even. And then this final one is A13, so again this. Now A22 here, so that's in the correct position, and then A31. So this one, you just need to swap this one with the top one to bring this one up into the correct position and this one down into the correct position. Okay, so we get a negative sign there because we only need to do one permutation, so it's an odd one. Okay, so that is the equation for the determinant of a higher order matrix. And basically, what you will see is that a clever trick in this case is to look at this again. A11, A12, A13, A21, A22, A23, A31, A32, A33. And basically, you can write this as being equal to A11. Now, so if you pick A11, as we did in these first two cases up here, we picked A11, then what can you pick after that? You are restricted. You cannot pick anything from this column here. So you're only considering really this smaller thing here. And also note that A11 is in the perfect position. So you do not need to worry about having to move A11 at all. So if there are permutations that need to occur later on, they're going to occur between the elements down here because this one's already in the perfect position. So what you could write this as is as A11 times the determinant of this smaller matrix, A22, A23, A32, A33, because this means, again, pick every possible combination that you can have, which is, after you've picked A11, that is you want every possible combination of these ones that you can have, because remember, up here we said we could have this one or this one, and then we'd be fixed with those two, and that's, again, the determinant of this, every possible combination of picking two there, and then obviously put the correct signs in for how many you're going to have to, how many permutations you're going to have to make, but that's going to be the same whether or not the A11 was there originally. So it is indeed A11 times the determinant of that. Then we'll have to put on the A12. So now let's say we have our A12 here. Okay, this is more complicated because now we're saying, okay, A12, we've picked A12. That means we can't go in the second column, so we're restricted to this bit of the matrix, picking our next bits. But the problem here, well, firstly, we know it's going to. We know we're going to have to pick from these bits, so we can put this determinant A21, A23, A31, A33, because that's how many ways there are of picking the elements after that. Picking elements such that you only end up with one element in a single column and one element for each row as well. So, because you can't select from this column, and obviously you can't select again from this row, so it's only going to be the selections from there, and it can be any permutation of those, because there isn't any limitation on that. The problem is that you're going to have to do an extra permutation than you would have had to do here, because this isn't in the right place. You're going to have to permute this down to here, and you'll bring something up here, but it will stay, as far as what I want to convince you of is that it's not going to alter the number of permutations you have to then do to get things in the correct order here. So if you think about this, this is going to put the element that was you were going to pick an element from here, and it was going to put it. It was going to okay, I think the best way to explain to you why that's going to be a minus sign, because you're going to add in this extra permutation of swapping the A12 with whichever element is going to be in the second position here. Okay, but I want to convince you that it's not going to alter. It's not going to alter how many permutations you have to do to get these bits in correct order. Because let's have a look at this. A21, A23, A31, A33. When you take that determinant, you will get A21, A33, because that was in the correct order, even though it wasn't in the correct order as far as this matrix was concerned. We're taking the determinant of this, so it's asking how many permutations does it take to put your choice. So in this case, we've chosen these two elements, and the sign of this is determined by how many permutations it took to bring this one up, to bring the element that you chose from the first column up into the first row, and to get them all in their right positions. But of course, when we look at this in the context of this, you're not getting it into the right positions, you're getting it into the wrong positions. You're bringing up the element in this column, you're bringing it up effectively into this position here rather than this position here. So you're asking how many permutations would it take to get it completely right up to the fact that you've brought this one up to here, and then all you have to do is then switch it with that one there, with this one here. So that's one permutation that you're going to have to do to switch it into the right position, basically. Okay, phew. So that's why that's got a negative sign in front of it there. Now we get even more complicated as we go to A13, because now it's even more complicated to understand how many permutations it's going to take to then correct everything after that. Okay, so let's say we do pick A13, then again we've got, well, I'm not going to put that plus sign there, because even though I know that's the answer, we need to convince you that that is indeed the case. So A13, you pick A13, this element here, let's just underline it there. Then what you've got is you've got to pick elements solely from this portion of the matrix here. So you're going to get the determinant of A21, A22, A31, A32. Okay. And then what we've got to ask is how wrong is this permutation? How wrong is the sign of the elements in here going to be? I.e., the sign of these elements is going to work about. Well, what it's going to do is it's going to put the element that's in the first column, it's going to put it in the second row in this matrix. The first row with respect to this matrix, but the second row with respect to this smaller part of this matrix. And then it's going to put the element in this column here, in the second column, it's going to put that on the third row. So what we're going to have to do is we're going to have to switch this one and this one around. So we're going to bring this one down here, and we're going to bring that up to the first row. And then what we're going to have to do is switch this second one with this first one now that it's gone there. So we're going to have to do two extra permutations on top of the permutations that you had to do within this matrix to get them into this right order in the first place. For instance, if you picked this one and this one, you're going within this matrix, you're going to switch those around, and then what you're going to have to do is switch them back twice again. So you're going to get a plus sign in front of there because it's adding an extra two permutations on. Okay, so that is a way of calculating the determinant of a 3x3 matrix. It is A11 times the determinant of A22, A23, A32, A33, minus A12 times A21, A23, A31, A33, plus A13, A21, A22, A31, A32. Now you can apply similar arguments for much higher order matrices. So for instance, if I take the matrix A11 all the way up to A1n, out all the way down to AN1, along the way to ANM, then if I take the determinants of that matrix, let's just put a little det here, oh no, sorry, I've put the vertical line, so I don't need to do that. Then it's equal to A11 times this smaller bit, so it'll be A22 all the way along to A2n, all the way down to AN2 2 all the way down to ANN. Oh dear. And then we'll need some more paper. Okay, minus, because you're going to have to do this one switch with the first row to get it into the correct order, minus A12 times A12, sorry, not A12, A21, all the way along to, oh, well, not, you wouldn't have the column A22 in this one, so I should put A23 there. Okay, and then you'll go along all the way to A2M, down to AN1, AN3, all the way along to ANN, and then you will obviously go along all the way up to plus A1N minus 1 to the power of, well, what's it going to be to the power of? If you were A11, you were to the power of 0. If you were if you were A12, you had a negative sign in front of you, so clearly you need n plus 1. Okay, so then we'll have this bit of the matrix left here, which will be A21 all the way along to A2n minus 1, all the way down to AN1, all the way along to ANN minus 1, etc. And that's how you would calculate the determinant. So I just want to do one quick example of how to calculate a determinant of a 3x3 matrix. So let's just make up an example. So let's make as small numbers as possible so that we can do it in our heads, hopefully. 1, minus 1, 2, 3, minus 1, 1, 4, 0, 1. Okay, hopefully those aren't linearly dependent. Right, so okay, so we can write this as, this is at the first bit, so we take this one, and then we 1, and then we times it by the determinant of this smaller matrix down here, minus 1, 1, 0, 1. Then we get this one here, we would have a minus sign, but it's got a minus 1 there, and then we get 3, 1, 4, 1, and then we get plus 2, 3, minus 1, 4, 0. Okay, so this is equal to minus 1 plus the determinant, well, sorry, I've skipped a step, I won't skip a step. You get 1 times the determinant of this, which is minus 1 times 1 minus 1 times 0. Then you get plus 1 here. The determinant of this is 3 minus 4. And then here we get plus 2, the determinant of this is plus 4, because you would have 3 times 0 minus 1 times 4, which makes plus 4. Okay, so you'd get that the determinant is minus 1, this would be minus 1 here, so you get another minus 1, and then here you get plus 8, which is overall equal to 6. So that's how you would calculate the determinant of a 3x3 matrix.